All right, what's up, everybody? Welcome if you're here early for This Week in Cyber. We're going to go over some of the top cybersecurity news stories this week, and there are two really interesting stories to cover for this last 7 days. Up first, there was a new vulnerability from a WordPress plugin that was disclosed. Now, if you use blogging, or if you do blogging of any sort on the internet, or you've been around reading blogs for a while on the internet, you can't have not heard about WordPress. And so just making sure that we're all on the same level. What is WordPress? WordPress is two things. It's a service that provides blogging platforms for people, but it's also an open source software solution for creating blogs and other kinds of websites. And I've made, I don't know how many WordPress sites at this point in my life for myself or for clients. It's a great platform, but some of the underlying technology that it's built on, in particular the PHP programming language, has some inherent tendencies toward vulnerability in the language. And so, in fact, one of the first things that you learn when you start doing web application testing is how to exploit PHP. Okay, so WordPress has a very rich plugin ecosystem where you can extend the base functionality of the WordPress content management system with these third-party plugins. And a lot of them are really great, they're really helpful, but they also tend to have vulnerabilities in them, and a massive one was disclosed this week in a plugin called WordPress File Manager. As the name might suggest, it's pretty common. It's a pretty popular plugin. I think over 600,000 installations had been tracked at the time of the disclosure of the vulnerability. There are a few interesting things about this vulnerability story. The first is that the vulnerability itself was a whopper. What we're talking about is unauthenticated remote code execution. So what that means is that a specifically crafted HTTP request, the kinds that we've been building here, you could send an unauthenticated HTTP request, meaning I didn't log in as a user of the site or even as an admin of the site, send that HTTP request to the server, execute code on the server, and get the result back. There are so many things that you can do as an attacker with this capability. One of them is you could download files to that server that then execute and give you a better, a more reliable entryway into the server. You can exfiltrate data like user accounts and any files that may be there. So RCE is a massive issue. So if you run WordPress and you run the plugin File Manager, make sure that you have it updated to the latest version. So the severity of the vulnerability is part one of the interesting, the part of the, let's try that again. The severity is part one of the significance of this story. Part two is how the vulnerability was introduced. A developer was working with an internal file as part of the project that was just used for development. However, in order to make it executable code, the extension of the file was changed so that it was just a .php file along with all the other PHP files that make up the plugin. When that happened, and when the file was then introduced into the production code, it was made available for everyone running that version of the plugin. So not only was this, it wasn't really a programming error per se, it was a development process error that led to this vulnerability because someone introduced a development tool into the production environment that should never have been there in the first place. This happens more frequently than you might expect, and it goes to show that it isn't just technical controls that are necessary to protect us from security incidents and vulnerabilities. You also definitely need to have administrative controls. You need to have a clear process in which security is considered so that you don't make mistakes like this. All right. Story number two this week is about Slack, the popular business messaging application. Slack is, God, it's just everywhere. I no longer have to use Slack for work. I use Teams though, and I'm not sure that that's an improvement. But Slack had dominated the world when it introduced, or when it came on the scene a few years ago, it provides a lot of really great real-time collaboration tools for folks. It creates a focused chat area for people, especially now that so many people are working remotely. Slack is everywhere, especially in the tech industry. And Slack is of note because there's a web application version of it, and then there's a desktop client that you can download, right? You can have a separate application that doesn't live in your browser to run the Slack app. Here's the thing, though, about the Slack app. It is built with a technology called Electron. What Electron does is it takes a web application, meaning an application built with web technologies, HTML, JavaScript, all the CSS, all the stuff that you would usually load in a web browser, and bundles it up and creates an app kind of container for it. So and there are lots of apps that run this way. Slack, Visual Studio Code, the text editor, there's just so many. Telegram, actually, if you use the Telegram chat app, all of these are Electron applications. It's a great way to have to write one code base because Electron apps are cross-platform. They'll run on Windows, Linux, Mac OS. And you're writing in web languages, so your developer pool, your talent pool is a little bit wider rather than writing in C++ or Java or something like that, right? You have access to all of the web developers and designers to build your app. Okay, so why does that matter? It matters because it exposes the Slack application to a whole new set of potential vulnerabilities. And this week, a researcher, a bug bounty hunter, which is a cool kind of subsection of the security community, which we'll talk about in a second, discovered bugs in Slack that led to not just remote code execution, cross-site scripting, which is it's one of my favorite vulnerabilities to go after, in which you can inject JavaScript to execute on a web page. But it was also in-app redirection, so you could send people to a malicious site and attack them that way, as well as other kinds of remote code execution. So this was a really, really severe vulnerability that the researcher discovered. As I mentioned, this researcher was a bug bounty hunter. Now, bug bounty is a really cool semi-new development in the tech industry and the security community where organizations will host their platform on these sites like HackerOne or BugCrowd, and independent hackers will go ahead and try to find vulnerabilities in your code. The bugs are then submitted, and if they are validated and they can lead to a fix, or if they are severe, the researchers are paid a bounty based on the severity of the vulnerability. This vulnerability is really nasty. It's about as bad as it gets for an application like Slack. However, the bounty that was paid to the researcher was a meager $1,750. That is, by my estimation and the consensus of the bug bounty community, insultingly low for a vulnerability like this. GitHub, for example, has paid out for RCEs, tens of thousands of dollars. I think there was a six-figure bounty at one point. I think Apple has a top tier of like $1 million for its bug bounties. If you can crack something on Apple's platform, they'll pay out. So again, the two sides of this, the severity was one part, and then the way that the company Slack handled this vulnerability, not the best, because you don't want to develop a reputation of being too cheap when it comes to paying out bug bounties, because then researchers won't want to work on your program. So probably not the best move for Slack. They're a $20 billion valued company. They could probably have afforded to pay this researcher a little bit more. So hopefully this researcher will get compensation some other way, or Slack will adjust their payout for this bounty. But bug bounties are a really fun community. If you want to start learning how to safely hack on some things, it's a great way to get started. And HackerOne in particular has a great kind of training course on web application testing that you can go through. All right, it is after the hour, so we're ready to get moving. So welcome everybody to Hack Summer. My name is Taggart. You can follow me on Twitter there at mttaggart. Before we go any further, if you're enjoying the content that I'm producing here, it would mean a lot to me if you gave a thumbs up to this video, and if you enjoy what we're doing on a recurring basis, go ahead and hit that subscribe button. Helps me out, helps other people find this material. We're almost done with Hack Summer, but I suspect that there will be more content coming out throughout the fall and other seasons in this same vein of technology, open source software, and cybersecurity. So if you want to see more, make sure you hit that subscribe button. What we're doing right now is we're looking at Python, and we're looking at cybersecurity, and we're looking at security through the lens of Python. What we started doing last time was building out kind of our capstone project for Hack Summer, which is a tasks app that runs a server code base and a client code base. And we are putting it all together. We started with the design, the flow chart of how the application is actually going to work. We thought a little bit about our data model, and we played around with the Flask library for creating web servers in Python. And we learned how to kind of send data to Flask applications. We even played a little bit with curl in Google Cloud Shell to simulate the data coming into the server. Now, as the data going into the server gets more and more complex, and we think a little bit more about how that data flow works, simulation is just not going to cut it. So we might as well take some time and build out a little bit of the client code so that we have something that will send the right data to the server. So we're going to do a little bit of client code today as well as server code. We're going to start on the client. And we haven't really built that out yet, so we have to think a little bit about the design for our client. Now, what we're going to do is we're going to be building a command line interface, but the way that we build it, somebody could, even you could, create a graphical user interface that ties into the same Python functions if you want it. But we're going to start with a command line interface because, well, it's just easier. Because we haven't done graphical programming in Python is not the best, but it's also because that's kind of the environment we've been playing in. So let's hop in and take a look at our command structure and how we would parse command line arguments and start sending some of this data to our server. Okay, so to kick off, I have here a CLI command structure document. I just whipped this up to explain how we're going to write our commands. This is a pretty common mode of working with command line interfaces. So what we're going to do is we're going to posit something called taskclient.py, and let's make that file right now with touch. So the idea here would be we'd run like Python taskclient.py, and then after that we would add some sort of command. We call them subcommands. And whatever the subcommand is will determine what we actually do with the application. So taskclient.py, and if we add init after it, right, what that would do is we would set up the actual configuration. And this is going to be the first thing that we have to do before we do anything else. We're going to have to configure our client to connect to the correct server, have the right username, password, things like that. If we ask for tasks, that is going to query the server that we've previously configured and retrieve the list of tasks. Add is going to kick off the process to add a new task. Tasks also has an extra little option flag that we can give it for -i for inspect. And so what my thinking is, we're going to ask for tasks. It's going to show us kind of the short list of all the tasks with like the title and then the due date, right? But then if we want more details on the task, that long description that we're accounting for in our data model, in case you remember, we're going to have a description in the data model, right? So we need that, and then delete is going to delete the specific numbered task, which we'll get from the numbers here. So that's kind of the basic idea. We won't build out all of these commands today, but we're going to get started. And in particular, we're going to work with init and add. All right, so let's come over here to Task Client and start building out a little bit of what we're going to need. All right. Because we're working with command line arguments, we know that we're going to have to import the sys library because we're going to have to get sys.argv. We've done that before to access command line arguments. We also know that we're going to be speaking in JSON, both for our configuration, which is going to be a JSON file, and also when we send data off to the server. So we're going to go ahead and import the JSON module as well. We're also going to kind of call our shot here in terms of the application structure just a little bit. This is a personal preference, but I like to keep my code very clean and separated. So for that reason, all of the functions that do the real work of whatever happens to the business logic of what happens to manage the tasks, I'm going to put in a separate module. And so to do that, I'm going to make a file called client_lib. Now there's nothing in there yet, but there will be. And because of that, I'm going to say from client_lib import everything. So any of the functions or classes or anything that I need that I need to work with, I'm going to put in the client_lib file and then import them so that I have access to them. And you'll see the rationale for that structure very, very shortly. Okay. The first thing I need to do, I have, the set of CLI commands that I'm accepting, right? And there are libraries built into Python that will help us create a command line interface very, very effectively. In fact, let's quickly take a look at one of them, opt_parse. I want you to know about this, but we're actually not going to be using it. Oh wait, not opt_parse. Sorry, arg_parse is the right one. I was a little behind on my Python. As you can see, it's fairly comprehensive, and in fact, the reason we're not going to use arg_parse is because it's too much. Okay, it's too much for what we need, but it's definitely something worth knowing about, especially if you like what we're doing here with command line interfaces and you want to build out your own. I've used arg_parse and its predecessor opt_parse a bunch for tools that I've built, and it's crazy handy. So something to know about if you want to keep playing with command line interfaces on your own. But for now, we're not going to need arg_parse. We are, however, going to have to account for these subcommands that we're accepting. So let's go ahead and in a constant, write the commands that we're willing to accept. So we know we have init, add, tasks, and delete. Okay? We will use that to check that the subcommand provided to the command line is valid. And if it isn't, we'll exit out. Usually when you mess up a command, the usage is printed. So it kind of says, oh, hey, it looks like maybe you don't know how to use this command, so we're going to show you how. And we're going to do the same thing here. So we're going to write a helper function called print usage. And in fact, this belongs in the client lib. So that's going to be our first function over here in the client lib, which is print usage. And really, really simple here. We're just going to print a string, just like this, usage, and then Python task client.py, and then inside these square braces, this is just kind of a convention for how we do this, right? We would say, what are our things that we can do? Init, add, tasks, delete. And I'm using the pipe to separate those. That's it. That's our print usage. Let's go ahead and make sure that it works and make sure that the import works. So I'm just going to call print usage here and do Python test client.py. And it works, right? So the usage is printing out. I haven't done any checks for the subcommands yet, but the usage is printing out the way that I would expect, and the import from the client lib is working. So we're good to move on. As always, if you have any questions, feel free to drop them in the chat. I am watching the chat as we go, so if you have anything that you'd like to address further or review, I am watching that carefully. All right, let's go ahead and then start writing our main function. The first thing we're going to do is get the subcommand, whatever the subcommand is. So it might not be there, right? So we're going to look for it in sys.argv. I'm going to call it cmd, sys.argv, and we know that the first option given to the script is the index 1, right? Because 0 is actually the file itself. So whatever is in that first position, that's going to be our subcommand, and it better be one of these. But it might not be there at all. And in that case, what would happen is an index error. In fact, let's show that. Let's take our time and show what happens when we don't provide an argument. So if I do this, right? Oh, gotta call main. There we go. Okay, so you can see that this failed because I didn't give it anything, right? As a subcommand. And notice the specific error that I got, the index error. Because that's so specific to what happens when I don't provide something there, I'm going to make that a specific exception. So I'm going to try to get that subcommand, and then I'm going to accept index error. And I'm going to very specifically print no command provided, and then print the usage. So that gives me a little bit more context for when the application fails. So you see now I get a little bit more information and then I get the usage, right? Whereas if I give it something, I don't get any errors back. Now, one thing I'm also going to do, because there's going to be extra code below this, is I'm going to sys.exit, which kills the application, and I'm going to give it an exit code of -1, meaning general error, something bad happened. Okay. Now, after we get our subcommand, and let's comment as we go here, right? We get the subcommand, and then we're going to validate the subcommand. So we say if cmd not in commands, right? So we're going to check to see if it's missing from our list of commands. Then we're going to print unrecognized command. And again, we're going to print the usage just to help out the user. And same deal, exit -1. Now we could be a little bit more specific about the different exit error codes, right? So for debugging, we could say like this is exiting with -1, this is exiting with 1, or whatever we wanted to do. But for now, we're just gonna keep it this way. All right, let's see if this works then. So if I give it that same nonsense, what it should tell me is that it was an unrecognized command, and it does. If I give it something real, then it's passing through. I don't have any code that handles that yet, but we're working through our code. piece by piece, and so far everything's looking good. Okay, let's start with init, because that's what we got to start with, right? We have to initialize the setup of the client before we can do anything. Now, this is the way that we handle this. I have to say, it's one of the things that I don't love about Python, which is that it's missing some structures that other languages have, but specifically things like a switch case statement for long sets of conditionals. But we'll make do, and we'll make do with just a couple of ifs here. So the first thing we're going to do is, now that we've validated the subcommand, we can make specific conditions for our different commands. Now we could be a little bit more clever about it, but this is going to work for clarity. So if cmd is equal to init, then we're going to call the init function. We haven't made the init function, so we'll have to go do that. And we'll also do add. If cmd equals add, then we'll call the add function. Neither of these exist yet, so we're gonna comment these out for now so that we don't get yelled at. And instead we're gonna just write a pass statement for each of these, which tells Python, hey, I haven't implemented this yet, but don't worry about it. Now let's go ahead and add them. Let's go make those functions, and in particular init. So we're going to head over to the client lib file and write some of these. Now, before we use this, we're going to, well, we can write init without doing any extra stuff. So let's think about what we need to do for the config, because what init is going to do is make the config file that the application uses. What do we need? Well, we need the user data, right? So for now, this isn't going to be the way that it works finally, but this is how it's going to work for now, which is we're going to do first name, last name, username, password, and the server URL. That last one is super important, because if we don't have that, we can't connect to the server. Now, you might notice that that's what we just said is a little bit different than the data model that we described here, right? Because we didn't talk about user ID. There's a reason for that. For one thing, we're not building it perfectly on purpose, because we're going to work through the development process kind of that way. But in addition, we haven't worked with how to create user IDs yet, and how to do this in a secure fashion. That's up for kind of later sessions. So for now, we're going to worry about first name, last name, username, and password, and then the server URL. And then we'll iterate on that to improve both functionality and security. All right, so to do this, we're going to ask the user for each of these pieces in turn in the init function. So first name equals input, and it's just going to be it's not going to look that pretty, right? But it's going to just look like this. Username equals input, and password equals input, password. Now, if you're thinking like a security person, this should already be raising some red flags for you. And if it doesn't, that's okay. When we run init, you might notice why this is problematic. Server URL equals input server URL. Okay. And then what we're going to do is we're going to build a dictionary, a dict, for the config data. And it's just going to be made of these pieces with the correct keys. It's not particularly exciting, This is kind of the drudgery of application development, right? You just kind of have to do the tedious work. But this is what makes the application actually function, and this is what people do, day in, day out as software developers. Eventually, what you do is you end up figuring out ways to make this a little bit more elegant or automating it in some way, and that's important for having to work with large code bases. Oh, good. Replit has decided to disconnect. That's always exciting. Well, let's copy all this just in case. Reload the, yeah. That was weird. Okay. This is one of the shortcomings of working all in the cloud is you're reliant on somebody else's computer, which I don't love, but it makes it a little bit more accessible for everybody. I will tell you that this is not the way that I usually develop. I don't use Replit to write my own applications. I use my own computer and then GitHub to save the code, and then I'll use cloud service providers like either Amazon AWS, Google Cloud, like you saw, or my personal favorite is DigitalOcean to spin up Linux servers in the cloud that host my code. That's kind of how I work. But Replit is a great place to learn and experiment. And I've actually been using Replit a lot more recently for not just teaching Hack Summer, but also like exploit development. If I'm trying to test an exploit, I need to host remote code for attacking or receiving data, I'll use Replit for that. Okay, so we've got the config data. Now that we have all this information, we've got to write it somewhere. We need the JSON file, the JSON library for that. So we're going to import JSON and leave that there. Now we're also going to create a constant here, which is the name of the config file. Just config.json for now. We're not going to get too creative with that. Now, we could also make that user configurable, but for now we're going to hard code it with open. We're going to open the config file, and we're going to open it in write mode because we have data to write to it as F. This is the beauty of JSON, the JSON library. We're going to do json.dump, which turns the dictionary into a JSON formatted text. And we're going to, so we give it the file, or we give it the data actually first as the first argument. And then we give it the file pointer that we're going to write to. And we'll leave that now and we'll play with it to see how it works. And then we're going to add something to it later to make it a little bit easier to read. Okay, let's go ahead and run our code here. So Python taskclient.py init. Why didn't that work? Because I forgot to uncomment init. Because now we've implemented that. We don't need the pass anymore. Let's try that again. Okay. Enter some data. Password. Okay, ready? Huge problem. I should not be writing this in plain text, right? Python has ways of entering passwords in asterisks, so you don't have to do this. But also, as you'll see, there's another problem here. And the server URL is going to be let's run the server to get the URL that we have to speak to. You might remember this from last time. I have to specify the host is global. That right there. is what I wanted. Please don't use my server. Please use your own. You can make a copy of this with fork. Wherever the fork command is for this. It actually is, if you start editing the code, you'll make a fork of it. Okay, server URL is right here. Okay, so init just ran, and now you can see that we have a config.json file in our folder here. And so it's pretty readable, right? What we're gonna do, we're gonna run this again, and we're gonna just add one little thing here, which is the indent parameter to the json.dump, give it a 4. And what this is gonna do is it's going to pretty print the JSON, meaning it's gonna give line breaks and indentations to the JSON file to make it look kind of like this, actually. So let's just see what that does. Okay, so now if we look at the config.json, you can see that it's formatted a little bit more cleanly. I just prefer to do that so that I don't have to worry about line breaks or anything, because if this is human editable, this is still a huge problem. This should not be there. It should not look like that. We should be hashing our passwords if we're going to store them. We shouldn't be storing them in plain text anyway, but for now, we're going to do that because this is how we highlight security problems, is we demonstrate them and then we fix them. Okay. So we have our init code basically set up for now. And let's go back over to our client lib. Now that we have a config file that ostensibly exists, we're going to try to get it whenever we need it. And we're going to write a function specifically for that. So I'm going to put it underneath print usage, and we're going to call it load config. And we're going to write this as a function rather than as a global for a couple of reasons, one of which is testability and maintainability. But another reason is application state. We talked a little bit about application state way back when we were doing the rock, paper, scissors game. If you remember, application state is the... Let me put that up there so we can focus on that. Application state is the set of information that describes what's going on in an application at any given point. Well, as far as the client for our tasks application is concerned, the state is defined entirely by the config, because when we go and get the tasks, it's not a state that the client knows about. It's a state that the server knows about. So we're just getting data from the server and we're presenting it. It's not stored, right? It's not stored locally, not the way that we're building the app. We could do it. We're not doing it that way, essentially for convenience and clarity. But so the state is the configuration. In the event that something were to change between operations when the client library is loaded in the configuration, whatever it is, right? If we decide to store something else in the configuration and that changes from time to time, we want to load the latest version of the config whenever we need it. So that's why we're doing it as a function rather than like loading it up when we get the library and then just keeping it in memory. Okay, so we're going to load the config. How do we do that? We're going to attempt to open the config file, which remember we created as a constant up here. We don't need the W because we're opening it in read mode with this. Now, what we're going to do once we open it is actually just return the result of json.load from the file. That returns the dictionary. And the reason is I'm not trying to set a global variable here. I'm trying to get the data whenever I need it. So I'm returning the data from this function rather than setting like a global variable, right? I'm not doing this. I'm not saying config equals load config. I'm not doing that up here in the global scope. We haven't talked a lot about scope, but it's worth mentioning now. Up here, outside of any of the functions, that is the global scope. But inside of functions is the kind of the local scope. It's scoped to the function. And even inside of conditionals, we can consider that a different scope. Python is really messy with the scope of its variables, and so we have to be careful about where we define things. So I'm trying to avoid global variables wherever possible, and that's why we're doing load config this way. Now this might fail, right? The config file might not exist. So if it doesn't exist, we're going to do the thing that I hate, which is returning a different data type. But in this case, it actually matters because returning none will validate as false, right? Which we saw before, which will be our indication that something's wrong with the config and we need to run init instead. All right, so that's all init. I'm going to close init so we don't have to worry about it. Okay. Now let's go talk about add. This is where we need to load our configuration file. So this is where we would go to add a new task. So we're going to load our configuration. And then we're going to if config, meaning if config exists and isn't none, then we're going to do some stuff, which we're going to say pass for now. And then else, we're going to print no config found, run task client.py init. And let's head over to the task client file and uncomment the add function since now it exists and remove the pass. Let's test the failure state of this first by renaming the config file. I'm going to use the mv command to do that. Mv is move, but moving and renaming things are the same thing. So it's one command to do either one. So we're going to do mv config.json, and we're going to do just config.json.back for backup. Okay, so it no longer looks like a JSON file, and it won't be something that our code knows how to look at. So now we're going to do Python task client.py add, and then it tells me no config found, run task client.py init, which I can do, but I don't need to because I actually do have the config file. Okay, let's change that back up. So we're going to rename the config file.back to the config.json. All right, now if we run the add command, nothing will happen because we still have that pass in there. Let's go ahead and write some code. If we think back to our data model for the task, what does our task require? It requires, I'm going to stop the server here because we're probably going to have to make some changes to it. What does our task require? It requires a title, it requires a description, and it requires a due date. Now the user ID, like we don't have that yet, so we can't really give it. We could give it the username, and we'll start with that. But as you'll see, it's not the greatest way to do it. This is, user ID numbers should be unique and sequential, or at least unique. And but we'll play with username for right now. So we're going to just replace this user ID with a username in the data that we collect. Okay, so to get the task details, we're going to ask for the task details. So we're going to ask for the task's title. the description, which is kind of the details of it. The due date, which is going to be, we get to play with the dates in code, which is the worst. Well, no, it's the second worst. We're going to get to do the worst thing, which is authentication, but that's coming up later. We're going to ask that the date is formatted this way. Now, this is not as detailed as it should be, right? Or as it could be, right? We're only asking for the year, the month, and the day. If you are not in the United States, I apologize that the days and the months are reversed to you. This is the way that we do it here. I know that it's different than it is everywhere else in the world. We also use feet, so we're kind of messed up that way. But this is also an actual standard for how we write dates. So we're going to use it. But we're not talking about time, right? We're just talking about the date. And so that's kind of limiting, but it's a good place to start. Okay, due date, and then Good. That's all we need right now for the task. I'm sure that you can think about other things that we might want to save in the task data, but for now, that's what we're going to do. So now we have to build out our dictionary that we will then send off into the web. So what does that look like? Well, we need the title, of course, which we have. We need the description, which also we have. Due date. Also got that. And then let's do username for now, which we're going to change up, but for now, that's what we have. Well, we have that too, but we don't have it in what we just collected. We have it in the config file. And remember that we have this as a dictionary now, so config username should absolutely be there. Okay. And now we have to send it. We have to send the data off. In order to do that, we need the requests library, which we've seen before. And with the requests library, we're going to R is just short for response, right? So we're going to do requests.post because we're using the HTTP post method rather than get to get data. We're sending data, which is we have to use the post method. Where are we sending it? Well, we're sending it to the config. Let's actually create this as a separate variable for clarity. Is the config server, server URL plus /tasks. Is there a slash on the end of that? There is not. Okay. Something you just want to think about is whether your URL has a / at the end of it or not, and think about how you want to handle that. 2 slashes doesn't actually matter, but you just want to be careful about things like that. So /tasks is how we're going to create the URL. So we're going to post to that URL, and we're also going to give it the JSON named parameter in our function, and that tells the request library, take this dictionary. It actually accepts dictionaries, not json.dump or whatever, and we'll turn it into the proper format and also give the HTTP request, the HTTP post request the correct headers so that the server recognizes it as JSON. Okay. Now, let's just quickly take a look at our server to see if this is even configured to accept what we have so far. Looks like it is, right? Because we have the app.route/tasks. We're handling post, and you can see that we've got this going on here. So we have add tasks set up, and everything looks pretty good. Let's go ahead and print the response though, just so that we see the result here when we're done. Okay, so I'm going to run add title finish tasks app description. Due date. What is our due date? It's actually I think it's the 28th is our last. It's the 26th. Okay. So 2020-09-26. By the way, you can see already that I did make a simple typo, which is here I should have added a colon and a space, which that'll happen the next time the application runs. Okay, so we got a response, but I got a 502, which is because I stupidly did not restart the server. Yeah, let's try that again. Okay. Well, good. Now we'll fix that typo. Finish tasks app. (2020) 26. Okay, well, we got a 500. That's different. And so let's see what happened over on the server side. Look at that. Interesting. Okay, so the reason why I didn't get an error printed out is because I did wrap this all in a try and accept, and so it's kind of obscuring the exception. So to make this a little bit clearer, let's see what actually went wrong. By just like we did with accept index error over on the client, we're going to make this a little bit more general. In fact, more general than Python usually likes, which is accept exception as E. And then we're going to print E, whatever that is. Okay, so we know that we got into here because something went wrong and we got a 500 rather than a 502 or something else. Let's also just look at tasks.json to see if there's anything in there. There is not, which is fine. But we definitely want to see what that exception is. So let's go ahead and Control-C to quit the server and then rerun it and then come back over to our client. Now, this should already start to feel a little tedious to you, like how we're sending all of this off. With having to write it through. It makes sense if we're doing it as a user, but as a tester, it can be kind of tedious. We could write a kind of an extra option for add where it looks for a JSON file that we have configured, and it'll just send whatever's in that JSON file. That's something to consider as a feature. For now, we'll just play with it this way. Okay. Finish tasks app. Hope you don't mind if I just do a little copy pasta here. Control-Shift-C, not Control-C. Whoa. Okay. I guess I'm just right. Unfortunately, some of these keyboard shortcuts are overloaded in my browser, so I'm going to just go ahead and right-click and copy. Great. That was actually slower than just retyping it. Okay, so we got the 500 again, but what did we get over on the server? Nothing. We got this task back. Oh, of course. So this is actually built out a little bit differently, right? Remember how we're doing data task like this? That's the problem. Duh. Okay, so we don't need this structure anymore. We were doing this mainly to structure out the like the quotes and brackets when we were playing with curl. We were embedding the test data inside of this key task, but we don't need to do that for this. We can just do it like this. That should look fine. Okay. Once more, because now that we know that the data actually looks correct based on what we're getting here, right? We're seeing the correct data come in. So now that we're not looking for a key that doesn't exist, we should be okay. One more time. Okay. And we got a 200. That's what we want to see. 200 means everything's good. Okay. And if we take a look at our tasks.json, hey. Now we have tasks in here that are stored with the correct username, right? Which means we can start asking for a user's specific tasks back. All right. Let's so we're going to focus then on the server code just for a minute, because we now know that we're getting tasks into the server. We're able to store them appropriately, right? And so we're going to now handle retrieving just a specific user's tasks. While we're here, by the way, let's also do a little bit more cleanup. Where we have we're no longer going to return all of the tasks, because we don't want the we don't want every user to get every other user's tasks. So we're just going to make a response success, spelled correctly. We're not going to send the tasks back that way. And then also we're going to modify save tasks here, and we're going to give it that indent equals 4, because I want my task JSON pretty. Should probably close the parentheses. Pro tip. I'm just going to rerun this add again with a new task, because let's say debug task server. I'll fix them bugs. And that's going to be due, let's say, the day prior. Okay. So got it back. If I look at my tasks.json now, yeah, I now have 2 tasks in here that match, that have been saved appropriately. And you can see that the username is in there. Okay, so how do we get just my tasks? Before this gets any longer, I'm going to split this up the same way that I did with the client. So I'm going to make a new file over here called serverlib.py. And we're going to move a bunch of these business functions like add task over into that file so that I don't have to worry about, I don't like messy code files. I would prefer to split them up into separate modules so that I can target things to test and to develop. That is also why everything I'm doing is in functions, because I can test those functions independently. And we'll talk a little bit about testing strategy at the end here. But for now, let's take save tasks and add task, cut them, and already tell our app to import everything from the server lib. Throw these in here, and then just note that we know that we're using make response here, right? So what we have to do is from Flask import make response. I think that's all we need from Flask in this library. And we also need the JSON, right? And in fact, we're going to restructure this a little bit. Over here. Now, you can see that what's going on here in the server is that when the server starts, the tasks file is loaded once, and then when we go to add a new task, 2 things happen, right? We're appending the task to the running list of tasks, and we're also saving it out to the JSON file so that when the server restarts, it will load the new data. The other way we could do this is we could do it very similarly to what we have going on in the client, which is we're loading the config every time we need it. The reason we're not going to do that really in the server is because the server is going to have a lot more, theoretically, it's going to have a lot more reading and writing to do. So we're going to take advantage of the memory that way and not have to do that much loading. Whoa. All right, there we go. Sometimes I wonder if these connection issues are because Replit hates the way that I'm using it with this, like using the shell this way, but whatever. Okay, so we have tasks here, and tasks is a global variable for us in the server side. Okay, so we've moved this over, and if I go back over to app.py, this all looks right. I'm returning add task and returning json.dumps tasks for the get. Now, this is actually a bad idea, right? Because now if I just ask for tasks, let's run the server. Oop. Got to run it with the -h option so that it speaks to the internet, not just locally. Okay, so let me pop that open in a new tab and go to /tasks. We have to modify this a little bit. Right, because there is no tasks. That's actually an interesting question. Let's go. That should show me the tasks. I wonder why it's not. It must be a scoping thing, but we'll fix that. So first of all, I should not be able to get all of the tasks when I just ask for the get method, right? I have to provide something else. Now, what I'm going to do is I'm going to use the ability to provide get parameters in the request. And you may have seen this in other websites like /u equals whatever. As a matter of fact, if you're watching this on YouTube right now, if you look at the URL, you should see like a $V or something, and then the ID of the video. So these parameters are sent in the URL. We call these get parameters. And if we look at the API for Flask requests, it has a property args, and with that I can actually ask for things that are sent to it. So I'm going to say I'm going to actually get the user variable, the user arg, up here. Equals request dot args dot get, and then just the u, right? And then I'm going to say elif user. Then we're going to get user tasks with the user. And then else return we're just going to json.dump an empty string and give it a 200. Because, well, we'll give it a 200 for now, but it's actually, the problem is that they're not authorized. Okay, let's rerun this. And let's see here. All right, what did I do wrong? Maker response. Very good. Good job, Taggart. Let's also, we're going to get an error when we try to do user tasks because we haven't implemented it yet. So let's actually just throw that in here in our functions. So def get user tasks, and we're going to print the user just to, and then we're going to return just to test it, just to test this, where this isn't actually getting the tasks, right? We're just testing to make sure that the server is working. Okay, so I should get an empty list here. And then if I ask for $u equals test. Okay, so now it says getting tasks for test. That's working. And then empty taggart, of course. Okay. So we're getting somewhere. Now we have to specifically get those tasks. There's a more elegant way. Oh, so we have all the tasks. Now we might have tasks from a bunch of different users. So what we have to do is match the ones that do. This is a very common problem in programming, right? It's a very, very common structure of a code task necessary to do. There's a much more elegant way of doing this, but we haven't covered a really important part of how to do it more elegantly. So to start, we're going to do this using the tools that we know. And the tools that we know, going back to our 4 structures of programming, right? We have loops and conditionals. So a little bit of loop, a little bit of conditional, and we're golden here. So what we're going to do is found tasks is an empty list for t in tasks if t username equals user found tasks dot append t. And then all we do is return make response json.dump s found tasks, and we also want to give it the inside of the tuple that we give to make response, give it a 200 for the status code. Okay, let's try that. Come back over here to our URL. All right, what'd I break? JSON is not defined. Right. Let's try that again. That also would explain why it was providing the empty list before on the /tasks, because it errored out accessing the JSON library. Okay. How about now? Oh, key error username. The reason that happened is because we have one of these blank tasks in here. Now that's a good safety to think about. What if your data is malformed? Right? We can and probably should put this in a try except. And then if so something goes wrong with trying to access that, let's just say like accept key error. We'll just continue steps to the next iteration in a for loop without doing anything. Okay. We could have also just deleted that empty task, but it's good to write defensively, right? You want to have robust code so that you don't error out on silly things like that. And who knows, you might get malformed data. Okay, but now look at this. We're getting our tasks back. So the last thing we want to do then is implement that tasks function inside of our client. That's the last thing we'll do today. So coming back over to our client, we first have to do our conditional if cmd equals tasks. Then we'll just do tasks like that. Got to write that function. So we're going to collapse the add function and the init function because we've taken care of that. So the first thing we need is we need to load the config, right? Just like we did before. I'm going to say URL equals config server URL plus, and then we're going to add that URL parameter like so, dot format, config username. Okay. And then r equals requests dot get from URL. And we're going to say print r.json. What did I forget to do? I forgot to do that 404 means I didn't go to the right place, which of course I didn't, because I need to do /tasks in there. And also this is a method call, so I need to do that. Let's try that one more time. Okay, we are getting data back from the server now. So we now have a connection between client and server. So we're getting data back. Now we're not printing it out particularly prettily, which we can write a function to do. And we're going to do that just so. For t in tasks. Actually, we're going to do this a little bit differently. We're not going to do for t in tasks. We're going to do something a little bit cooler. We haven't played with this yet, but there's a built-in tool called enumerate. Enumerate will take a sequence and return a tuple, which is the first element in the tuple is the index, and then the second is the value. Is the item itself, and you'll see why that's kind of cool. So for enumerate tasks, so for I comma t in enumerate tasks, I promise this will make sense in just a second. We're going to print I, and then so format. So the first thing we're going to print out is I plus 1 for reasons, and then t title. All right, coming back over to our task client, we're going to say tasks equals you know what? Let's just write it this way. Let's just leave it all in the client lib. And we'll send print tasks the response like so. Okay. So that all happens when we ask for tasks. And you can see, look how clean that is, right? Finish tasks app, debug task server, and we have these nice numbers that are a little bit more human readable. That's why we did the I+1. If we wanted to do a little bit more, we could also say in here, T due date. Right? Not too shabby for our first session. So we're going to leave the code there for the moment. Now, hopefully, even with what we've done so far, you can see a lot of security issues with the way that we've built this app. That's intentional. I hope you're thinking about that way. Thinking about how could somebody else access somebody else's tasks? How could somebody modify tasks that I don't want them to modify? How could someone break my server? There are a lot of things in here that are worth considering. And again, that's definitely intentional. We built them that way so that you can think about those, and then we go back and secure the application in the development process. Now, we talked also about testing strategies here, and I want to just call this out for a moment, because building in Python, there are a lot of different approaches to building applications in Python. This isn't really just a security question, but security, I think, is advanced by good development strategies. The first thing we want to talk about is how do you modularize your code? If you build with functions the way that we've done, you can take each piece and then test each piece. I will also say that when I do development, I will have a running Python shell with the module that I'm building loaded into that Python interpreter so that I can test the function as I go to see what's going on. Now, this is kind of a modified, that's called a REPL style of development, where you have the read, eval, print loop. That's what REPL stands for. It's a modified version of another style of development called test-driven development, or TDD. And I think one thing that we can take that's really valuable from the concept of TDD is the notion of what's called red-green refactor, meaning you build your function and you build a test for your function that the test should pass if your code is working the way that you want it to, that the output of your code is what you expect. So you build your test first, okay? Then you write your function to fail. So you write your function to fail, the test fails. Then you go back and refactor your function's implementation so that it passes the test. Now, this might seem like a lot of extra work because you have to write the test for everything that you do, but over time, that extra investment pays off because you're guaranteeing that every part of your application works. Test-driven development is really, really popular in the web side of the house, working with JavaScript. It's a little bit squiffier over in Python, but there are libraries like PyTest to help you build testing approaches for your application. But I really do prefer first just building in functions and then developing live with the REPL as I go. Now, for larger, more formal projects, I think a testing scheme does matter. But we can talk about that a little bit more. But for now, I just wanted you to think about those ideas of red-green refactor, especially in the way that we've even discussed writing our functions, where we call our shot, right? We write our function, we think about what we're returning at the end, and then we kind of go back and re-implement it. So some things to consider as you're writing your own functions and you're building out your own applications. But this was good work for today. I think we've covered a lot. If you need to go back and review what we did, please do. One of the things that we always encounter, right, there are certain errors, and that's kind of intentional. I wish that I'd never made mistakes, but that's not how people work. So I'd much rather you see the mistakes getting made, and then you can see how we debug them. So I would recommend going back and just checking that out to see how we did the debugging. But that's going to do it for this week. If you're enjoying what we're doing here and you feel like giving back, I really recommend that you check out the charity Human IT, who are giving low-cost internet connections and computing devices to families in need. We're into the school year here now in the United States, and folks are still definitely without adequate access to the internet and to computers with which they need to go to school. It continues to be an issue. So if you feel like donating either lightly used devices or financially, you can check out Human IT at humanit.org. That's going to do it for this week. Next week, we're going to continue down with the client and the server, adding some features, and hopefully we're going to get into authentication next week so that we can see how we can fix some of the security holes that we've introduced so far. All right, thank you for joining us here at Hack Summer. Happy hacking, and we'll see you next time.